the object class is the top level class for any program that you write in Java. So you don't have to explicitly inherit or extend the object class. You just inherit from it automatically. So we look at the main methods provided by the object class. What can, should, and should not be overridden. Instance of this, which you're probably familiar with already. And we look at some key methods. So we're going to focus on some key methods, which are equals, hashCode, toString, and we'll consider adding a method called valueOf. Okay, so valueOf does not exist in the object class, but we'll look at its benefits. The benefits of having it within your class, within your classes. So, so the object class is the top level object for anything that you might write. So for example, if you write this program, then you will automatically inherit from object. You don't have to declare it anywhere. It just happens automatically. But also, this happens for any of the libraries that exist within Java. So you can make use of lots of libraries within Java to make your life easier. For example, the string class, the random hierarchy, the collection hierarchy. So all of these also extend and inherit directly from the object class. So these are the methods. These are the main methods within the object class. So we've got so obviously you've got object here. So this is this is your constructor. You've got the class method. Sorry, not the class method. The get class method. So you can make use of this method if you're not sure of the type of an object or what class it belongs to. Then one thing you can do is say p.get class, okay, and it'll tell you that the answer will be person. Okay, so it's a useful thing to have, and there are many situations where this happens. So, for example, you might have a method, and lots of types of objects can be passed to that method, and you can do things with that object. The first thing you might want to do what that object type is, before you can do something with it or not. There are a number of methods here which are associated with concurrency control. So this is notify all, wait. So this is wait repeated 3 times. So this is an example of overloading. Yeah. So you're calling. So this is one. So in the first instance of the first type of the method, there are no parameters. In the second one, you can have a long timeout. In the third one, you can have a long timeout, and you can have it in nanoseconds as well. So these 5 methods are associated with concurrency control, and we're not going to look at them on this module, because concurrency is a big topic, and if you want to study concurrency, then you can go ahead and do it by yourself. But it's not something we're going to cover. And you notice that all of these methods, from get class to the concurrency control methods, have the final keyword. So you can't override those methods. So that's the key thing. So you have to use them as they are from the object class. You just say, within any of your Java programs, if you want to do concurrency control, if you want to get the class name, you just call the method and you pass it the right parameters, and it just does whatever you want, what it's intended to do immediately. Now you've got a number of other methods which you can override, and these are clone, finalize, equals, hashCode, and toString. Okay, and the main ones that you should override are these ones here. Most of the time, you should override these methods. It's advised that you do override them, and you write your own code for them. These 2 here, it's advised not to touch them, just to leave them alone. Okay, so the clone method, it was intended originally that you can use it to clone an object, so you can create the same copy of the same object. Okay. And if you don't, and when I was a student, I thought, oh, that's neat. I can just copy my object very easily. And I remember I was writing a computer program to draw some shapes on the screen, and I just thought I'd clone rectangle, and I'll put it within my menu, and you just right-click copy, and you paste it somewhere else, and you create lots of copies of the same rectangle. But then I noticed when I was resizing one of the rectangles, all of the other rectangles resized. And when I reduced one of the rectangles, they all reduced. So it does a shallow copy. Okay, all of the shapes that are drawn on the screen were pointing to the same object. So it was just copying the reference. Okay, and somehow it was managing to draw lots of shapes on the screen. I didn't quite understand what was going on. But then I realized that what you have to do is you have to override clone. You have to put it within your own class, and you have to you have to copy every single parameter physically by yourself. So for example, you need to copy all the parameters of the object that you want to copy: its size, its dimensions, if it's a rectangle, for example, its color. Every single parameter needs to be copied, and you have to go deeper than that. If any of them are objects, you have to copy them as well. You have to go deeper, and you have to copy everything. So clone on its own here is not very useful, and the advice is not even to use it, because there's no point, because you have to do all the copying yourself anyway. So why not just create your own method to do that? So yeah, so in order for you, but if you do want to use it, if you don't want to override and you just want to use it as it is, you want to create a shallow copy, you can't just do that. If you try to use the clone method within your class, then an exception will be thrown. Let's jump to the next slide. You'll get a I think it's the next slide here. So you'll get a clone not supported exception. Okay, so if you want your class to use clone, then you have to explicitly tell the outside world that your class is going to use clone. And the way that you do that is that you implement the clonable interface. So any class that wants to use clone has to, or override clone, has to implement the clonable interface. And then you get rid of this exception being thrown. Okay? So yeah, so let's have a look at the methods. So we've got these that I mentioned. So get class returns a representation of our object's runtime class name. So you've got notify all, and the wait methods used for concurrency controls. And then you've got these here that can be overridden. Okay, and the advice is not to override them, not even to use them. The advice is just like Java, because finalize is used by the garbage collector, and it automatically deletes your objects when they're not referenced by anything. So Java will automatically say, okay, these objects are no longer referenced by any references, and puts it and just decides, let's just delete these from memory, and reallocates memory to other objects. And clone, as I said, is pretty useless, so there's no point in using it anyway. So the problem with finalize is that there's no guarantee when it will run. And if you want to use finalize, there are some exceptions when to use finalize, and that is when you want to release resources that are outside of the control of your own virtual machine. So if, for example, you're connected to a database, or you're connected to the internet, some remote objects, and you want to explicitly tell your program, I no longer need this database connection, I no longer need these network resources, that's the only time when it makes sense to use finalize, because your Java virtual machine can't really know whether or not you want that database connection still or not. So that's when it makes sense to use finalize. But normally, if you've got your computer program within the single machine, then it doesn't really make sense to use finalize. Look at the clone method and read more about it. That's in Joshua Block's book, item number 11. If you want to read about finalize, then you can read Joshua Block's book, item number 7. So the methods that we do want to override are, the first one is equals. So by default, equals, if you don't override it, will operate like this. Okay, it will check the identity of the object. It will check, are these two objects identical or not? Is it the same object or not? So it returns true if two references refer to the same object. So it just does an identity test. It doesn't do an equality test. If you have some other notion of equality for your objects, then you need to define what that equality is for you. So you need to override equals if logical equivalence is required. Another important one is hashCode. Now hashCode returns an integer value of an object to support hashable data structures. So there are a lot of data structures that make use of hashcodes, so that if you want to find one of the objects, it searches by the hashcode and it jumps straight to the hashcode and finds the particular object that you want to use. And because of that, if you decide that if you override equals, then you basically created some notion of what it means for two objects to be the same. Then logically, if those two objects are equal, then they must return the same hashcode. even if they're two separate objects. If they're two different objects, but for you they're equal, then for you they also must return the same hash code. So there's a contract within Java that you must do for any class that you create. If you override the equals method, then you must override the hashCode method as well. If you don't do that, then you'll get very, very strange results. It'll run, but you'll get some very, very strange behavior. So you must override hashCode if you override equals. Okay, so we'll look at how to do that in a bit. Another important method is toString. And the aim of toString is to return a string representation of an object. And it's good practice to override toString, but you don't have to. So if you just use it as it is, then it'll print out something. I think it'll print out the object's location in memory. But if you wanted to print something else, something more useful, then you have to tell it what to print out. Okay. So first, before we look at all of these, we'll have a look at this and instanceof Boolean operators, which are useful for overriding equals and hashCode. And then we'll look at equals and hashCode, and we'll look at toString as well. If you've written any programming language, then most high-level programming languages will make use of this reference. So it's a reference to the current object. So if you need a way to refer to your object, then you say this dot. So you can do something like this dot, call a method on the current object. Okay. So it provides access to shadowed members. So these are member fields with the same name as the method parameters. Okay. So if you want to access, for example, the person's age, then you can say within your code, you can say this dot age. Okay. So and therefore you access the age variable, the top level age variable. So this way you differentiate it from the age variable that exists in any of the other methods. So for example, if you declare int age a, for example, in any method below, then you need some way to differentiate it from the top level age variable. And the way you do that is by making use of this parameter. You say, for example, this age is equal to age, and so you assign age to this age. It can be used to detect aliasing. So this means when a method parameter may refer to the object on which the method is invoked, in which case this is equal to parameter. Okay, so if you want to detect whether or not a parameter being passed into your method is the same parameter within your object, then you can do this comparison. So this equals comparison method. You say if so this is an if this is equal to parameter, then do something. Okay, so you're basically checking if the parameter being passed in is exactly the same parameter within your object. It also supports constructor chaining, so you can do this as well. So if you've already declared a constructor person, okay, and it takes an integer for an integer name and for example int age. So if you already have a constructor person int name and int a, okay, and you want to create another constructor, so here we're doing some kind of constructor overloading, okay, where you allow the user just to pass the name, okay, so you don't want to have to repeat the code that you've already created in this constructor, okay, so you can do this. You can say this name, you automatically pass the name to this constructor, and you say if they don't want to pass the age, for example, I'll just assign it to be 0. So you can do this if you like, and therefore you call the other constructor that you've already written a bunch of code for that you don't want to repeat. So this is another use of this parameter. So you can call another constructor that way. So that's called constructor chaining. So it's a runtime test for the type of a reference object. And the way it works is you just say reference instance of class name and return true if reference is an instance of the class name. If reference is null, then you'll get false. So because null is not an instance of any class. Okay. So if somebody passes a null object that's or passes a reference that's pointing to nothing, basically, it doesn't have an address to point to, or the object is just not there, then you'll get false whenever you execute that. So one condition is that if ref is an instance of class name is true, then it's true for all superclasses of the class name. Okay, so if reference is an instance of lecturer, it's true, then it's also true for university person, it's also true for person. So there's a question here, what does reference instance of object evaluate to? Yeah, so that should always give us true, because object is the top level. So even if ref contains student or integer or if it contained car or whatever, if you apply this test, is it an instance of object, it should always say that it's true. Yeah, so use instance of before a type conversion to text, and the conversion will succeed. So that's the example that I showed you. So that's here. So you're saying is P an instance of lecturer. So that's the example that we looked at for instance of. Right, so let's, okay, so this is equality versus identity. So we've kind of looked at this before, but we'll cover it again. So as we said, the default object implementation of equals tests for object identity, not logical equivalence. So that's what it does. So so if you don't override equals, then O1.equals O2 gives you true only if this is true also. Okay, so it has to be the same object. So here's an example. Let's say you've got person A is equal to new person, and you've got these parameters, these parameter values, and you've got another reference pointing to a completely different object, but it has the same parameters. So even though A and B are logically the same, but they do not refer to the same object. So by default, if you say is A equal to B, then it will return false here. Okay, so we've already seen this example. So we need to override equals, because obviously this doesn't really make much sense in this case. The first thing that we need to understand is just have a reflection on is the equals contract. If you want to override equals, then you need to keep these things in mind, and they're quite important. If you don't keep them in mind, then it's very easy to make an error when you override equals. So there are some things you need to think about. The first thing is that it's reflexive. So x.equals x must be true. So that's kind of might sound obvious, but it's something that you need to check for. So so this is what we mean by aliasing. So am I passing the same object to myself? Okay, so so when I pass into the equals method a bunch of objects, have I passed the same object? So that's something that you need to check for. The second thing that you need to check that you need to make sure of is symmetry. So if x is equal to y, then y must be equal to x. So when one object is a superclass to a subclass, and x, for example, is a superclass to y. Okay, so if you've got an equals method within the superclass, then you're only checking the parameters within the superclass. So you're only checking, for example, for age and name. Okay, and then if on the other hand you've got another equals method within the subclass, then you're also checking some other parameters. You're checking, for example, for their institution and their stage, the university they belong to, whatever other parameters. So if an object is of type of the superclass, they won't have some of those parameters at the bottom. Their values will be 0, they'll be null or something like that, so the objects will not be equal. Whereas if you're checking from the super type, then you'll only be checking those parameters that everybody's sharing, so they will be equal. Okay, so that's an example where you don't have symmetry. So therefore, if you have an inheritance structure, you have to be very careful. You have to decide, where am I going to put the equals method? You can't have it in everywhere. You can only have it at one level. And you have to decide at which level you want to put the equals. Because you need to make sure that it is symmetric. And you have to make sure that you're always only checking the same parameters. You don't want to be one equals method at one level, checking some parameters, and another equals method at another level, checking another set of parameters. Again, for the same problem, it needs to be transitive. So this is the same problem. So x.equals y, and y equals z, then x equals to z. Also, it needs to be consistent. So for multiple invocations of x equals y, it's consistently always true, or consistently always false, unless you change x or y during invocation. That just means that you check all the parameters correctly. For non-null x dot equals null should always be false. So you need to check for null. And the default equals implementation satisfies the contract, obviously, because we're not actually checking any parameters. You're just checking for identity. So you're just using the equals method within the objects class, and you're not overriding it anyway. So by default, the equals implementation satisfies the contract. So if you override it, then you must make sure that you satisfy this contract also. So there is a this kind of a recipe that you can follow. So there are a number of things that you need to check. So let's say we've got we've got an example here. So we're looking at the equals implementation comparing just a person's name and age, for example. So let's say, so the way that you override equals, you just declare it within your class. So this here is placed somewhere within the person class structure. So you've got this new method now, and these are the things you need to check for. So first of all, reflexivity. If this is equal to right-hand side, then return true immediately. It's the same object. Okay. So you're checking this. So this is an example of what I was talking about earlier when I was talking about where is it? Aliasing. Okay. So you're passing the same object into the class. So you're checking, is this being passed through here? So are you passing the same object in? If it's the same object, if the object being passed in is the same as my object, then return true immediately. It's obviously the two objects are equal because they're the same object. So we've tested reflexivity there. Another thing you need to check is non-nullity. So that after you've done this check, if it's not the same object, then you do a second check. You move on to the next if statement. A simple way to check for non-nullity is to check whether the right-hand side is an instance of person or not. If it's not an instance of person, then return false. And by doing that, you're also checking that it's not null. Okay. So obviously, null is not an instance of person. So it's a quick way of checking that it's the right object type and it's not null. So if right-hand side is not an instance of person, return false, and you exit, and the two objects are not equal. If it is, however, an instance of person, then we move on to the next level, and this is where you check in for consistency. So you need to check every single parameter. So we take our right-hand side object here, we cast it to person. We've already checked that it is of type person, remember, before we did this. So you cast it to person, and you say person p is equal to the right-hand side. And so now we have access to the member variables, and then you just return, and then you just check every single parameter. So is age equal to p dot age? We've got age and their name, okay, separated by an and you're just returning what the result of this logical relationship is. So for this to return true, then this must be true and this must be true. So if any of these is false, if this is false and this is true, for example, then the whole relationship is false. And if they're both false, it'll be false as well. So first thing, we check the age. Age must be equal to p.age. Also, the names must be equal, but you need to check name for non-nullity as well. Okay. So if name is equal to null, then this name must be equal to null as well. If they're not both null, then it's the same object as well, which is fine. If name is not equal to null, on the other hand, then name must be equal to p.name. Okay, and the string object. So name in this case is a string. Okay, and a string object automatically has its own dot equals method. So string overrides equals. So you don't need to do anything after that. So you can just say p.name and it gives you the string value of the name. So basically, what you're doing within this box here, what you're doing is it's an if-else statement. You're saying you're checking this logical statement. Name is equal to null. If it's true, then you look at the question mark part. Okay. If it's false, then you're looking at this part. So if this is true, then you look at this part. If this is false, you look at this part. Okay. So it's just an if-else statement. So if name is equal to null, then p.name must be equal to null. If name is not equal to null, then whatever the name is must be equal to the p.name. So this is where we've checked all the parameters. We've checked is the age the same and is the name the same. And before that, we've done our essential checks, our basic checks. We've checked that it's not the same object, and we've checked that it is indeed an instance of person, and that it's not null. Okay, so this is the basic recipe of how you would check for equality. So this is this, and if you've got more parameters, so it's up to you to decide what it means for two objects to be the same. So so for a person object, obviously the age and the name need to be the same. If you're checking equality at the student level, then you need to check all the other parameters as well. So you need to say age is equal to age, and name is equal to null, and you check the stage and any other parameters as well. All of them need to be checked. Okay, so so our example followed what we call the general equality method pattern. So yeah, so we're checking. So within the pattern, the things that we did, we tested for identity, and returned true if this is equal to right-hand side. It tests for non-nullity and for type. So we said if, and the way we did that, we checked if right-hand side is not an instance of this class. And then the next thing we need to do is cast the right-hand side to the correct type. And then we compare all the significant fields. So we use equals for any object fields. Okay. So you might want to compare some object fields, but you might also want to compare the primitive type. So in this here, the age is just an integer. So we didn't use dot equals to check it. We don't need to use dot equals. It's just a simple integer. So you just check it using this equality check. Okay. So use equals for object fields. If you've got an array, you can use arrays dot equals. So the arrays utilities class has got a useful dot equals method. If you've got a nested array, then you use something called arrays dot deep equals. For any of the primitive types, then byte, short, integer, long, boolean, and char, then you use this. For floats and doubles are also special cases, even though they're primitive types. Using equals might not give you correct results because the different way that operating systems and different computers do floating numbers in different ways. So floating numbers are complex cases. So what you need to do is to use their wrapper class. So remember I told you that each primitive type has a wrapper class. So you've got float for float and double for double. And you say, for float you would say use float to integer bits for float, and double to long bits. So basically you convert it to the number to its bit equivalent before you check in for equality. And that way you guarantee that that Java's doing it correctly. Yeah, so this is an example. So this is similar to the example that I told you about. So when we talked about symmetry here, symmetry and transitivity. So this is an example of showing you why you need to put equals method only at one level in the hierarchy. You can't have an equals method in the person class and have an equal method within the student class. You have to choose which way to put it. Otherwise, x dot equals y might be true, but y dot equals x might be false. So this is an example showing you why. So so two people with the same name and age are the same people, but two people with the same name and age at different institutions are different people. So that's something you need to keep in mind. So if you do the equality test at the person class, they'll be the same, but if you do it within the student class, they won't be the same, possibly. So let's say you've got an object of type, I guess this is an object of type lecturer, so LS36 at Newcastle and LX36 are the same person, and so are LS36 and LS36 in London. So let's say these are two different people. If you compare them from the person class, it'll tell you that they're equal. But if you compare them within the lecturer class, it'll tell you these are two different people. Okay, so you need to decide where you want to do it. So the solution is either institution is not significant or everybody must have an institution. So basically you need to decide where you want to do your equality test. So the equals method pattern that we looked at just a second ago does not by itself guarantee compliance with the equals contract. In general, it's not possible to extend an instanceable class and add a new field and at the same time comply with the equals contract. So basically we're talking about the same thing, same example before. So the solutions are prevent instantiation of superclasses, make all but the ultimate subclasses abstract. So this is a general design recommendation within Java. Ideally, the person class, you shouldn't be able to instantiate an object of type person, or you shouldn't be able to instantiate even an object of type university person. These are the top levels of the hierarchy, and ideally the person class should not be a class, it should be an interface. Okay. Also, the university person that sits in the middle between the person and the very low level classes like student and lecturer, that middle class is usually declared as an abstract class, and you use it to hold any common behavior that you want it to hold. So that's one solution. So you can do it that way. You can only make it put all the important methods within the subclasses such as equals, and you don't allow them to be run from anywhere above. Another way to do it, you can maintain all states in the superclass, which is a very difficult thing to do and not recommended, but it is a solution also. You just have the equals method in the superclass method, and basically all the subclasses are inheriting everything. It's a very strange design thing, so I wouldn't do that. Another solution is to use composition instead of inheritance. We'll also look at composition. Usually, implementation inheritance is not recommended within any object-oriented programming language. So what we've been looking at so far is what we call implementation inheritance, where every level of the hierarchy you can execute and you can create objects from. So that creates a very tightly coupled architecture, where if you change something in one of the levels, it'll have an effect on all the other levels. So that's something it's not really recommended. So solutions are to either use interfaces at the top levels, or you want to use composition instead of inheritance. So we'll talk about that later. So, but if you want to read in more detail from now, then look at Joshua Block's item number 8 for more explanation. As I said, another method that we need to override, especially if you override the equals method, then you have to override the hashCode method as well. So the job of the hashCode function is to compute an integer hashcode from an object. And it's used in different scenarios. And one of the scenarios, as I said earlier, was to be able to search for objects within certain data structures, like maps, for example. So a good hashCode function generates a different hash for different objects. Okay, so if you have a unique object, then it has a different hash function from other objects of the same class type. And the hashCode function essentially depends on the parameter values. So that tells you that to compute the hashCode function, you need to make use of the variables values that you have for your particular objects. So you would use the same recipe for all of the objects, but that generate different hashes because they have different values. Used by hash-based collections for fast lookup of objects. If an object's hashcode and equals method are incompatible, then the object will not work correctly with hash-based functions collections. So imagine you've decided, for example, that two objects are equal, but you've not correctly implemented the hashcode function. So two objects that are equal generating different hashcodes means that they're placed in different places within the table of the data structure, which is a bit strange. So if two objects you decide are equal, then they should generate the same hashcode function. Okay, the same hashcode. So this is the hashcode contract. Like an equals contract, it's a hashcode contract. So always override hashcode when you override equals. And the contract is this. It must be consistent, return the same integer as long as no information used in equals is modified. So two objects that you decide are equal need to return the same hashcode essentially. If x.equals y is true, then x.hashcode y is equal to y. Sorry, x.hashcode is equal to y.hashcode. Okay, so that's the essential contract. So those are the main clauses of the contract. So 3, if x is not equal to y, then it's not required that the hashcodes are not the same. Okay, if the two objects are not equal, then it's not required that x.hashcode is not equal to y.hashcode. So it could be that you have two objects that are not equal, but they might sometimes by chance generate the same hashcode. It happens, it's very rare, but it's possible and it's okay. Okay, and it's okay because it is very rare. And all that happens then is you have a clash within the table or within the data structure, but that's okay. So within data structures you've got your hashcodes there, okay, and each hashcode ideally only has one object associated with it within the table. Ideally. So you say, find me object with hashcode 1234, jumps to there, and you get the object straight away. And it's very fast. But if you have a clash, then all that happens is that you end up with 2, 3, or more objects next to the same hashcode. So what happens then is you just got to further search. So you find the object with the hashcode, and you see that there are 4 objects. Then you have to go do a bit more searching, and you look at each object. Is this the object I want? Yes, no. Is this the object I want? Is the object? So it takes a bit longer. You just compare it. You're just looking at each object and seeing if it's the right object that you're looking for. So we'll talk about that more when we looked at data structures. It just takes a bit longer, but because it's rare, it doesn't really matter if that happens. The hashcode contract is violated if you override equals, but you do not override. Okay. So this is a pretty good recipe to creating a hashcode. So it's taken from Joshua Block's item number 9. It gives few collisions for distinct objects. So you can never guarantee that there won't be a collision, but this recipe gives few collisions. So the recipe is this: choose an initial value and a multiplier. For example, you can choose your initial value to be 17 and your multiplier to be 37. So you set the hashcode initially to the initial value. So in this case, the hashcode first will be 17. So that's my initial hashcode. And then you use the multiplier in conjunction with the parameters in order to create the final hashcode. So for each field used to test for equality in the equals method, so remember we've already overridden equals, and when you override equals, you decide which fields you want to be the same. Okay, so you must use the same set of parameters that you've used in the equals method that you use to generate your hashcode. So for example, if you've got 6 parameters, like maybe 3 primitive types and 3 objects, and you decide that one of the objects is not important to you when you compare equality, then you can't use that object when you want to generate the hashcode. Okay, so you only use the same parameters you use within the equal method, you use within the hashcode method. So for each field used to test for equality in the equals method, update the value of the hashcode as follows. So hashcode is equal to the multiplier times the hashcode. So that would give you, in this case, 37 multiplied by 17. Okay, because it's initially 17, and then you call the hashcode method for each of the fields. For primitive, so this is for objects. This is for objects. For primitive values, use their integer equivalent or their wrapper class's hashcode. So for primitive, so apply the following transformation to primitive fields in place of field.hashcode. So for primitive types, so for byte, convert it into an integer using casting. Okay. For short, also convert into an integer using casting. The integer, you just use the number as it is. For long, float. For long, use. So this is how you do it. This is the recipe on how to do it. So there's a method called valueOf, whatever the field is, .hashcode. Okay, so you're just using that sequence of methods. For float, the same, you're using float, and the method for that is float to integer bits fields. I don't know why it's different for float than it is for long, it just is. Okay, so Java's a bit strange sometimes. For double, it's double.valueOf field.hashcode. For Boolean, you're just basically using its value. So Boolean means true or false. If it's true, use a 1. If it's a false, use a 0. Okay? And for character, you need to cast it to an integer. So characters are primitive types, and obviously you can't use characters in multiplication, so you need to cast it to an integer, and Java will do that for you. For arrays, use arrays.hashcode. So it's arrays for normal arrays, and for nested arrays, use deep hashcode. And if you want a complete explanation for all of these methods and why they're being used, etc., then have a look at Joshua Block's item number 9 for complete explanation of both the recipe and why we're using these. Okay? So as I said, you don't need to memorize these. So it's just if you want to create a hashcode method, then refer to this slide, or if I can find them online as well, and it'll tell you how to generate the hashcode for various objects and primitive types. So yeah, if you want to see an explanation for long and double hashcode from this slide here, then refer to Oracle's Java docs. So apparently this is not explained in Joshua Block's book, but you can look at Oracle's Java docs. Okay, so here's an example. So I want to override hashCode for the person class. So I'm returning an integer value, so the hashCode is an integer value, remember. So remember we used the recipe we showed before. You set an initial value to 17 and our multiplier is 37. So hashCode is equal to 37 times hashCode, which is 17, plus, so you're just adding all the different parameters. If name is equal to null, then return 0. So you check in for nullity first. So you always, when it comes to strings, you always need to check for nullity. Otherwise, your program can easily crash if somebody's passing a null value. So if name is equal to null, return 0. Otherwise, name.hashCode. So string has its own hashCode method, so you just make use of it. And then you just return, and age is just an integer value, so it's a simple integer. So you just return 37 times the new value of the hashCode here, plus the age of the person. We could have said hashCode is equal to, hc is equal to this, 37 times hashCode plus the age, and then returned hc, okay? So it's just a quick way of doing it. When not to override equals, there's no need to override equals when the logical equivalence is not important to you. So if you anticipate, you don't really care if two objects are equal or not. It depends on what problem you're trying to solve. So if they're not equal, if it's not important to you, then obviously don't override it. There's no need for it. When each instance of a class is inherently unique, when you know that you'll only ever create one instance of each object, then you can, for example, a menu item. For example, the file menu item. There's always ever going to be one file menu item. So there's no need to create any more instances of that object if you create an interface. So there's no need to override equals for that method, for that class. It just doesn't make sense. You just, if you want to check that this is the same object, then you can just use objects equal method, which checks for identity, if it's the same identity of the same object. When a superclass overrides equals and the inherent behavior is correct, so this is like going back to what I was talking before. If equals already been overridden in a class that you're inheriting from, then don't create your own, because then you can end up with problems that we talked about. So when a class is private or package private, and you know equals will never be invoked. So if a class is not intended to be public, and so the outside world can't make use of it, and you don't want to do any comparison of objects, then there's no need for equals either. So it's up to you to decide when it makes sense to override equals or not. And if you do not override equals, then definitely don't override hashCode, because you just make use of the hashCode method of the object class as well. Now moving on, so we've talked about equals, we've talked about hashCode. So the third method that we recommend you override for your objects to be useful to the outside world is this toString method. If you don't override toString, then I think it'll give you some information. It'll give you your class name at a memory location. Okay, so that's what will happen if you don't override toString. It'll just print what class name your object belongs to and where it is in memory, which is useful for some things, but I'm sure you want it to be more useful than that. So it's good practice to override toString. So if you add two objects together which are strings, so let's say p is equal to 1, 2, 3, so this is a string, and d is equal to f, g, h, okay, and you do p plus d, then you'll end up with 1, 2, 3, f, g, h, okay? So what's happening then is that you're given this value, these values to your object, and automatically toString will be called and they'll be added this way. So toString is automatically involved when using the toString concatenator and when calling print line. So something that the users of your classes will definitely do is they'll try and print your object and to see what happens. They're not going to, well, sometimes they will. They might call the toString method explicitly, but most of the time they're not going to do that. They're going to just try and print your object, in which case your toString method will automatically be called. Okay, so you can do this. You can system.outPrintLine p or d, and it'll just look for the toString method, and it'll print whatever you want it to print. So you need to give them something more informative than this default behavior here. So when practical, return all the interesting information contained within the object. all the information fields return them. So for example, if you want to convert a person object to string, then it makes sense to do something like this, which is to return the name and their age. Okay, so if the object values are John 35, then printing the object should say John 35. Okay, if you're using the student class, if you want to override the toString method within the student class, then you're also overriding their institution name and their stage as well. So always try and return all the parameters of your object. And the way to think about it is somebody should be able to use your toString method to reconstruct your object, to recreate your object. If you want to store an object to a database, for example, you usually call the toString method and use the toString method to store all the values within the database, and then you'll have all those values, so when you load it again, you can recreate that object. Okay? If you miss one of the values, then you can't create the object. So you have to store all the values. So that's why use your toString method to be able to return all the values. So notice we're returning the values, we're not printing the values. So that's another important thing. It's not your job to decide for the person using your class how they want to use it. They might want to use it to print something, but they might want to use it for something else, like saving to a database, or just analyzing the values in some kind of program or whatever they want to do. So and this is coming to so this brings us to this important method here called valueOf method. So always consider creating a valueOf method within your classes. And the reason for writing a valueOf method is that so you can automatically recreate an object from a string value. So users of your classes will almost always consider the return value of the toString method to be part of the interface or contract of your class. So people will always assume that you have this method within your classes. They will try to use it for returning a string and in order to get information about the object state. So it's important to you to document whether the format is subject to change. So you need to tell them what the format of your string is. So in this previous example, the format is here, is you have the name of the person, followed by this dash, followed by the age of the person. So when you document your classes, you need to make this clear, okay? Because they need to know what's separating the different string values. So to help them recreate the object later on. So they need to know that this is the separator. They need to know that the first element is the name, it's not the age. The second name parameter is the age, it's not something else like the institution. So you need to document and tell them exactly how it's going to, I mean, they can test it themselves. They can just use toString and see what happens, and then they can figure it out for themselves. But it's always good to document your work very well and tell them exactly how the toString method works for them. So yeah, so if you create this toString method, it's useful to provide a corresponding valueOf constructor to create an object from its string representation. So see details of that are described in blocks, Joshua blocks item number 10. So here's an example of how you can make use of that. So let's say I've used the toString method and I've loaded the object to a database or to a text file. Now I want to recreate the object. I'm restarting my computer and I want to recreate my object. So what I do is I call the valueOf method and I pass into it the string representation of my person object. I just load it from the database and it gets passed to the valueOf method. And now and this is an example of what your valueOf method should do. So you create an array of strings, because obviously a number of strings are coming in, and they have a number of parts. The person is a string, and strings have got a special method called split. Okay, so you can, if you've got a long string and you know that the string is made up of a number of different strings, you want to be able to figure out how that string is being split. Okay, so on here we're saying that this long string is being split by a number of dashes like that. Okay, so what the split method will automatically do, this single string here, it'll automatically split it into a number of strings. In this case, there'll only be 2 strings, and it'll create 2 strings for you. So once you do this, so this will be, so the split method will then place these 2 strings into this array. Okay, so now I have an array of 2 strings, and all you have to do now is get the values of those 2 strings. So the name is equal to array element number 0. So check first that it's not null always. If it's a null value, then it's null. Otherwise, return the value. Otherwise, return the value of that string. And age is equal to part number 1. And then what you do is you create your object. So you return a new person with these 2 parameters that you've figured out.